Yeah, the future of fashion, on-demand manufacturing as a game changer for supply chain transformation. Um, 6 years ago, I founded a startup called Tailor Technologies. And I did that because my background is in bespoke tailoring. And I used to make handmade suits. I used to sell made-to-measure suits. And when I started selling made-to-measure suits, I noticed very quickly that there was something off. You are purporting to sell a custom garment to your customer, but when it comes in, even with my skill as a pattern maker and my knowledge of fit, I wasn't able to deliver it right away. So we were spending anywhere between 60 and 120 euros per garment to do alteration costs after the fact. And I was like, okay, there's something obviously wrong here, and I think I can fix it. Because before I used to be a bespoke tailor, I was also a programmer. That used to be my background. And I married the two together. So just a little bit about myself. Like I said, I have a background in programming and graphic design before I foolishly became a bespoke tailor. I'm a 3D fashion and 3D transformation expert. And for the past 2 years, in addition to working on my startup, I've been a consultant for companies such as PVH, Alvanon, Style 3D, and lately Wacom. So the challenges in the way I see it in the fashion industry right now are quite clear. There's a problem with fit. Fit is very difficult. There's a problem with overproduction, there's a problem with pollution, and there's a problem with waste. So let's break each of these down. So sizing is confusing for the end consumer. When I am on the couch with my girlfriend and she wants to order something online, she always asks me, hey, can you recommend a size for me? And then I look at all the sizing tables and it makes no sense to me. And if it makes no sense to me, how can it make sense to anybody, right? Then when it comes in, from one brand to the next, you may have a medium, and then you have a large there, and then you have maybe an extra large over there, and there you have a small. So there's no consistency either. It's also very inflexible for brands, because your brand, the people who actually wear your clothing, may look vastly different than you think they look like, or the people that want to wear your clothing may not fit in your clothes at all. And so what do we end up with? Up to 15% of manufactured items are never sold. And up to 30%, in the worst cases, in e-commerce, they are also unsold. And considering that, that's a huge amount of garments. And then when we consider that even a simple t-shirt costs a mind-boggling amount of water to produce, what are we really doing? Well, this is the reality right now, but I think that we can do something about it. On-demand manufacturing. So on-demand manufacturing, while it may seem very far off, it already exists today at scale in the made-to-measure industry. I know of factories that create 6,000 unique items per day, and that's one of many who do that. And I also know a lot of manufacturers that do both. They do ready-to-wear for big brands, and then they do made-to-measure on the side. What they all tell me time and time again is that on-demand manufacturing is much more profitable, is much more manageable, and is much more scalable. Because instead of having these seasonal upticks where suddenly everybody wants everything right now or yesterday, it's just a steady flow. It's seasonal, but it's a flow. So you can plan, and especially the line engineers, they really like that if they can plan, right? So my thinking was that algorithms, they could generate manufactural patterns and markers according to the customer's own measurements. And automation from pattern generation to marker making to the cutting room could help a lot of unnecessary busy work. It's all about automation, 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 automation. So the case study is my startup. And so what do we do at Taylor Technologies? We don't have any sizes. We have a pattern algorithm. We use 3D body scanning and automation, and most importantly, manufacturability. So grading patterns, however well you do it, even if you really put your best foot forward and you grade your sizes on a sizing standard and all the way up until the big sizes, it's however well you do it, it's still inflexible. Because like I said earlier, if you want to sell outside of your target audience, what are you going to do? It's not going to fit. So our algorithm, instead, it generates a pattern based on the body measurements of the customer, right? And we use 3D body scanning to get those measurements. Our automation enables us to go to have 15 minutes from the order placement to the cutting room, literally to the cutting room, and we can do that at a rate of 360 markers per cluster per day. And per cluster, I say that because it's very easy to spin up a second cluster, and then we can do double, or triple, or quadruple. It's all based on automation. So when we were developing this, we started out with suits. And suits are very difficult. They're very difficult to fit because you're working with non-stretchy fabric. It's very thin, especially, for example, the Loro Piana fabrics. They're only 210 grams per square meter. And so you will see any and all defects in your fit right away. And we did that for a reason, because our thinking behind it was, if we solve it for suits, we've solved it for everything. Because everything from there is quantifiably easier, right? So what we did is we controlled for a lot of variables. We did testing on 150 bodies, and we kept the same construction, the same fabric, and we made the same images from the same height. We measured each of these customers by hand to establish a ground truth, and then we 3D scanned these customers as well. And that is all done to train the algorithm, because basically what we've done is we've poured all of the pattern making knowledge that we had, and between me and my other co-founder, that's a combined 45 years of pattern making knowledge. Even then, even with all our logic, there are points missing in that knowledge. And so by testing it on a wide variety of bodies, you can fine-tune the algorithm. Okay, so if this happens, let's say we see a defect in that specific customer, we analyze what we see, and we analyze the measurements, and then we will adjust the algorithm to next time better suit that person. So for example, this is a cool thing. You can see here that the back is a little bit too narrow, and so that creates these dimples at the back of the sleeve. So we said, okay, but he also has a very round back. So we analyzed his measurements and then adjusted the algorithm to suit it. But at the same time, what it did instantly, and I want to repeat that, this is all straight from a 3D body scan. We did no fitting whatsoever on these people. We just pressed a button and it came out like this. Because this person has a very, very, very round back, right? And this pattern fits him perfectly well. And you can also see, for those of you who are a little bit versed in pattern making, is that each of these backs are constructed differently. They have different geometries. And it changes that automatically. What we also did is we tested a lot in 3D. And we started with testing in 3D very early on, all the way back in 2017, actually. And we scanned every one of our test subjects. And it's pretty cool because each of these avatars each of these avatars are real people. And so what we were doing in reality, we also were doing in 3D. And 3D allowed us to iterate over versions of our algorithm much, much, much faster. And most of all, much cheaper. And we could also purchase 3D models. For example, this is a very well-known bodybuilder. And so we could test it on a bodybuilder without even knowing this person. About bodybuilders, we also tested it on very difficult bodies. These are bodybuilding people. This guy's pretty big, but this guy is huge. And a pattern algorithm like this is only as good as its flaws, because if you want to roll this out into the real world, it cannot be 98% accurate. It has to be 99.5 at least accurate, right? And so we attempted to break it by testing on these very difficult bodies. And being able to capture anomalies observed in these measurements strengthens the algorithm. So what have been the results? Well, here we have some results, and they were also not fitted, not altered at all. So this came straight out of the factory. This came straight out of the factory. This came straight out of the factory. And this is a size 52 women's avatar. And this sloper you see is generated instantly from our pattern algorithm. And these suits were delivered to the manufacturer and manufactured completely in an automated way. There were no phone calls, there were no emails sent. We already set up this pipeline to our manufacturer in Portugal. We hit the button. 15 working days later, we got our suits back and we gave it to these people. But I'm not going to lie, it has been very, very difficult. And we've had a lot of failures, and we still have a lot of challenges. Because if you see this, this is not very good. We have some issues in the sleeve, we have these drags on the back, and yes, granted, this person has very straight shoulders, and he's not that easy to fit. But this is also results that we got. It's not the picture-perfect ones which I showed earlier. And 3D body scanning still has to come a long, long way. Why? Because you can do 3D body scanning in a couple of different ways, right? We would prefer if we had the classic 4-pillar body scanner, because it's static and it doesn't move, and the person inside doesn't move, and it's very quick. It takes just 1 second, and you capture the body. But the thing is, that thing is static, and I need to put it inside of a retail store, and it costs 15,000 euros per piece, and so that's not really scalable, is it? So what I actually want is I want to use my mobile phone. But the mobile phone solutions that we have right now are not as good, because here you can see this person was scanned using a 4-pillar body scanner and has the appropriate shape in his back. And the orange line, which I hope you can see running through it, is the shape that we got from mobile scanning. If we do not capture this shape, we cannot adjust our pattern well enough, because the measurements don't have to be accurate. They can be 1 centimeter off, 2 centimeters off, but the shape needs to be good. If we can capture the shape, then we can capture it inside of the algorithm. And finally, limited funding made it hard to test this at true scale, right? Because we did this on 150 people. I think in total about 350. But the biggest sample size, the biggest test that we did was 150 people, which is rather big, but I need to do it on 1,000 people. Because only at scales of, let's say, 500 or 1,000 can you really start inferring whether or not your algorithm is performing well, right? So an all-encompassing algorithm is truly possible with the right investment of time, talent, and money. I really, really, really believe that. But algorithms such as these can solve the entire problem of fit and overproduction, reducing waste, reducing pollution, and increasing profitability. And so the way we see it, any garment can be made for anybody with any body type at any time on demand. And 3D scanning at home with the mobile phone, which will get good in 2 or 3 years, allows you to reach your customer directly inside of their own home, which potentially leads to less overhead from retail locations, or retail locations can become smaller and be more of an experience rather than, shopping through countless sizes and getting frustrated and then leaving at the end of the day and getting a drink because you couldn't find anything, right? So, and at scale, this would become cheaper than ready-to-wear, as well as faster than made-to-measure is today. Because yes, with made-to-measure right now, it still takes us 15 working days to get a made-to-measure suit in. And the example of the 6,000 pieces a day factory does that in 2 weeks. So that's 10 working days, which is really, really quick. But they also have the skill, so they can do that. And this is a very complicated, very technical garment with many, many, many layers and very highly engineered. But if you do this for a t-shirt, I am 100% sure you can do this much faster. 3 days, 4 days, sure, no problem. And automation, and that's what I've been skipping over for now, this algorithm that we created, the first thing I wanted to do with it, I don't want this to be made in some small workshop somewhere. That would have been too easy. I want to manufacture this in a real factory, right? And I want to make sure that when I bring it to a factory, that they are not hurt by me wanting to use my own patterns. So what we did, we worked with factories, and a lot of factories said no. Some of them said yes. And the ones who said yes, we worked very closely together, so we have the notches in the exact same position. We have the exact same paper templates that they use. We have the exact same markers that they use. You want 15 different markers for each and every one of your materials. This for this fusing, that for that fusing, this for the lining, this for the body lining. Oh, you want to cut checks? Sure. Checks and plates? Sure. But then you have to give us the cutting file like this. And we said, sure, no problem. So we created a nesting algorithm that does it exactly like they do it. So the factory workers in the factories that we work with, and that's 3 of them, 2 in Portugal and 1 in Mexico, never really know that it's our pattern that they're manufacturing. We even give them the data in the data format that they want, which in some cases is an XML file, in another case it's a JSON file, and in another case it's a PDF, a simple PDF. Depends on how much labor is done manually in these factories. We even give them that information, so it's cut, it's bundled, and it's put on the production line, and nobody ever knows. And they are really happy with that. Because you cannot go to a manufacturer and say, hey, look at these patterns, can you make them? Yeah, but then I have to change my whole production line. No, that's not going to work. So our algorithm, with just basically the switch of a variable, changes the seam allowances, changes the positions of notches, changes the amount of markers that are generated according to which facility it is being sent to, right? And finally, so I'm not sure if you guys read the article in the Financial Times that Sweden is now making new regulation to make sure that at some point they will ban the destruction of clothing, of unsold clothing. And the European Union is watching that very closely, and the European Union will likely take that over. So any brand in Europe will likely start having somewhat of a problem sometime soon, because they can no longer destroy the clothing that they don't sell. So regulation will soon force brands to do something. And I'm not saying that every single piece of clothing that we all wear should all be made exactly to our measurements, but we could at least start with made to order. And the way we do that is by using algorithms and automation to get there, right? We have all the computing power in the world, if we want, and we can use it. And automation, we are just 4 people. But we can still churn out these 360 markers per cluster per day while we're sleeping. And automation cannot make any mistakes unless you program it in the wrong way. It's not going to forget something. It's all completely automated. So, any questions? Oh, there we go. How can we improve / train ourselves and our teams for better understanding the pattern making? Well, this is something that like I said, I also do a lot of consultancy work. And sometimes I'm a bit like, okay, where are all the pattern makers? And then they get patterns sent over from the manufacturer. I'm like, yeah, but you need a pattern maker, right? So hire pattern makers, and I guess as an industry, we should also still strive to educate young talent in the verse of pattern making. Pattern making is very important. But what can you improve? You can hire an external pattern maker and teach people how to do real pattern making. That's what I guess. And apart from that, what I want to note is you also need to be aware of who your customer is and what body type they have and how you can develop on that body type, right? So you can, let's say, look up Alvanon or something and get some advice from them. What are the lead times for the made-to-order products, and do you present them online first with 3D to collect order quantity? So this product is not out in the wild, and we are still deciding on whether or not we want to do this directly to consumer or business to business or whatever else. But the lead times, it's 15 working days for a suit, and it's 5 working days for a shirt, right? We have tried various approaches to presenting them to customers. We've gone the way of a digital bespoke tailor, like, hey, we'll send you a render. This is you in 3D wearing the suit. What do you want to change? Do you want to change your sleeve length, or you want it a little bit tighter or something? Could be anything. But basically, from the minute you press the order button, 15 working days later, it's manufactured. How does the manufacturing process work in your case exactly? Most factories require high minimum order quantities to start production. So we went directly to made-to-measure manufacturers. And made-to-measure manufacturers, they don't have any minimum order quantities. They are used to having only 1 order in the beginning, and then maybe 5 orders in your second month, and then 10 orders in your third month, and on and on and on and so forth. And they do require you to grow, right? It's not worth all of their time if you don't grow. But we went to made-to-measure manufacturers. And I think, like I said, each and every one of these made-to-measure manufacturers told me personally, look, if I had the choice of completely abandoning ready-to-wear manufacturing today and instead start producing 1,500 custom orders per day, I would do it today. And I would wave goodbye to all the craziness of the seasonality, and I want things now, and this is not done well, and this needs to be done over. I don't want that anymore. I just want my factory to work. I want my people to not be overstressed and everything else. So we went to manufacturers that were already on that journey. How do you work with pricing and capacity planning of the factory without total quantity? Well, I do not work inside of a factory. I know a thing or two about factories, but I do not run a production line. So that's something that you have to ask a made-to-measure manufacturer. And I think as a wider industry, we can look towards the made-to-measure industry and maybe get some advice from them and ask those kind of questions. So how do you factor in all your pricing and your costing, and how do you measure everything? I know that example that I gave earlier of the 6,000 pieces a day, it's a very, very, very high-tech facility with cameras everywhere, AI tracking everything, and counting everything by the minute and by the centimeter and everything else. And so you will need to look at that. What is the percentage of claimed units versus order due to incorrect fit? Well, like I said, our sample sizes for now have not been big enough to finish the algorithm. The algorithm is not finished. I'm not going to lie about that. In order to finish it, I need that huge sample size of at least 500 to 1,000 people. So now I would say this algorithm works for maybe 95% of all human beings. So 95% of you I can put in a scanner and then make something that fits you very, very, very well. But 5% of you, the algorithm is going to make a mistake. So, would you be able to share customer feedback? What did the customer like and not like? And customization level. People find it difficult to see themselves in 3D. Because the way we see ourselves in a mirror is very different than the way we see ourselves, let's say, in 3D. Most people don't want to see it. They're like, no, that's not me. That's not me. That's not my body shape. But I think we can overcome that as soon as we. Right now, most 3D body scanning does not take any photographs, so you're just a gray mass, or you can give it some texture, but then it's still like one big mass. There are solutions, however, which we've also tested, where it scans you in full color at the same time. So it has your eye color and everything else in your skin tone and every little blemish. And then suddenly, we did a very small test with that. People were much more comfortable with seeing themselves. Still creepy though, because that specific scanner, even though it's completely unaffordable, really creates a digital twin of you. So that's rather scary. How do you compete with the sustainability strategies? What are your methodologies to provide a full traceable product in made to order? Well, there's nothing more sustainable than just making one product for one person, right? It's exactly what they need. It doesn't have to be returned. So that's how we differentiate it. So how do you make that quantifiable? Well, you can look at which facilities we've been using, and we've picked facilities that are working in a sustainable way. But like I said, the main point is we are only creating what is necessary and nothing more, not a single piece more than that. So, any questions from the audience still? I think that's it. We still have 10 minutes left, I see, but I'm happy to give that time back. Oh, so go. Yeah. Yeah. So with the fabric, that's a very good point because I completely missed that during the presentation. The way these made-to-measure manufacturers work is they usually have their own fabric testing facilities. They have ways to test pilling. They have ways to test, test the quality of the fabrics. They have their own warehouses, right? And we worked with the fabrics that the manufacturers had in their warehouses. Sometimes we also did, let's say, CMT, and we would send them our fabric. And that would then have a little bit more of a lead time because then the fabric first needs to be tested on shrinkage and all that kind of stuff. But the thing is, if you want to do this at scale, we are working several seasons in advance anyway. So it would just be a matter of, okay, deciding on the fabric and making sure that the fabric is correct and has the right color, put it in the warehouse and you can start producing, right? But these facilities have their own facilities where they can test their products on shrinkage. And that's something that's also put in the algorithm. So it will detect which fabric from the entire library is being used, and then it calculates the shrinkage that is required on the marker. So you cannot skip that part. It's very important in manufacturing.
Is this idea of yours and having the algorithm developed, do you want to apply that yourself and that you open a store and that people can come in and that you are going to, let's say, deploy it yourself? Or is your idea with this to go to Hugo Boss or another big company and say, okay, this is the concept, this is the technology, and you can use it? Is that
It's an open
an idea already about that?
It's an open discussion. Before COVID, we had a very clear business model, and then COVID happened, right? Because we wanted to just work with independence and be white label, and rely on retail stores and everything, and then the world changed, right? And right now, I'm more having the feeling like I would love to partner up with preferably a manufacturer or a very big brand, but preferably a manufacturer, and do this at scale, and then have them deploy it. That's what I would prefer right now.
Is your algorithm software, or how it works?
There's
Software and then yours?
So there is custom software behind it. We made our own pattern making software. We made our own marker making software. We made our own nesting algorithms. But we don't have that publicly available at all. So
But you can import inside
I cannot import anything. No, I cannot import anything. Cannot even import the DXF because it's all based on geometry, let's say. And if all the input is 0, then there's just one single point. The algorithm doesn't start working without measurements, and with measurements it grows, right? So we cannot take a DXF pattern. The thing is, we do have a library of standardized garments which we can easily adapt into something else. Because these suits, they need to have a lot of different possibilities. You need to have your peak lapel, your shawl lapel. You need to have your all the different shoulder types, a rope shoulder, a Neapolitan shoulder. You need to have a continental shoulder, all those kind of things, which we can all program inside. The suit algorithm for jackets for men consists of 280 small little pieces that get generated in about 10 seconds. That's the way it works. So if we want to do it let's say for a dress, then we have a base, and then the styling is a different part, of course. But the skeleton behind it is the same, right? I guess most people don't know, but if you have a sloper and that sloper fits well, from that sloper you can derive any pattern you want, right? So if the core fits, you can make derivatives of it. And I've only shown men, but we've also done this for women at a much smaller scale, but the algorithm is able to do that too. Sorry.
How much bodies can you need to have a correct measurement? It's human body, so some people.
How many measurements?
Yeah. Because
That number has grown over the years massively. We started with 25, and I think the latest version of our algorithm uses 250 points of measurements. And we dissect the human body. That's also part of the algorithm. It's a separate algorithm within the whole technology stack that takes the 3D scanned body and slices it up into pieces and starts measuring certain landmarks and certain depths and stuff.
it's a human body, so it changes things. Some people it's different in the one maybe.
Correct. So, yeah, so you always need to make sure that there is ease. And one of the main challenges that we still have is you have to, you can make it fit perfectly in a technical way, but some people like to wear their clothing very tight, and some people like to don't feel their clothing, right? So capturing the aspect of taste is something that also still needs to be considered. But I consider that not part of a technical implementation. Well, it would be a technical implementation, but it should be done at the sales level. It should be thought about when you have this tool, then you can start thinking about, okay, so how can we capture what somebody actually likes? And nowadays with AI, I think we can perfectly capture that perfectly. But yes, people change from morning until night, and people change throughout the year. Usually around Christmas, it goes up. And so the goal is to not make something so tight that it can only be worn in one season of a human body, let's say. So you need to have enough ease at the right places and comfort, movability. This jacket was also came just from the factory, and it has extremely high armholes, and because it has extremely high armholes, I can just move. I can move like this and do this, and my collar stays attached, and it's not tight at all. It has shape, but it doesn't look tight, and that's what you can do with well-fitting clothing. The gentleman over there.
Well, first of all, very interesting presentation, very comprehensive. So congratulations on that. In regards to this as well, have you factored in, have you considered this algorithm supporting you, let's say, to measure the new patterns for a second-hand garment? Because in the end, this is a new garment that you are providing to the individual, right? It's bespoke. Then, in order to close the loop of circularity, if this garment is sold to a second person, are you considering, I don't know, develop this algorithm to be capable to adapt, repair, or change the pattern? That will be the person that wants to buy the second-hand garment because of the fabric is not quality, appearance, but in the end it doesn't fit because it's nylon.
Well, that would be difficult, from a technical point of view, but something that tailors have been doing for hundreds and hundreds of years is putting inlays this size into their garments. So that's something that we did with the jackets, at least as well, is our seam allowances are this big, for example, on the back. So this jacket, if I eat too much or drink too much, then this jacket can grow a size if I needed to. But apart from that, I am a very big opponent of fast fashion. I think it's a ridiculous thing, and I think we need to go back to things that we are able to wear for a longer period of time, rather than wearing it for a season and then throwing it away. I don't agree with that, but I think it would be difficult to put back into the algorithm, right? Because how are you going to recut it, and are you then going to remanufacture it or something? All we can do is make sure that there are copious inlays inside of the garment, and I think we can do that with any sort of garment. Basically, we don't only have to do that with suits, right? I guess we can make a dress where the seam allowances are a bit bigger. I don't think anybody will notice.